Hello everyone. Now we're going to talk about skew of our data. So to begin with, I'm going to briefly introduce a concept we'll talk a lot more about in chapter 5. But if we have this bell-shaped symmetric curve, this is called a normal distribution. And you'll notice that it's a bell-shaped curve over this line, and it's symmetric, meaning that if we were to cut it in half, half the data is to the left, half the data is to the right. Now, when we have perfectly symmetric data like this, if you look at where the peak of the graph is, this tells you where your mode is. So in this case, the mode would be right here because the peak of our graph is right above the center of this normal distribution. Well, if you also consider that this represents where we're located, so our data, we have half the data to the left and half the data to the right. This means that this is also, that center is also the median. The height of this graph represents the magnitude or how much of the data falls there. So this actually means that if just as much data falls to the left, not just the number, but how much of it, how big it is, as to the right, this means that this center point is also the mean. So when you have perfectly symmetric normal distribution like this, your mean equals your mode equals your median. Now, this is why I mentioned previously that we actually oftentimes can use mean in place of having median, because if we can show that we have normally distributed data and that it's basically symmetric, then we can actually use the fact that median and mean should be equivalent for this data. And of course, as I said, mean is a lot easier to work with. Now, what if you have data, though, that's skewed? So let's say it looks something like this. So with data like this, you have a tail to the right. This is called right skew. So this data is right skewed. So again, if we look at where the peak of the data is, our mode would be here. But if you look at the distribution of where our data points are, we have more data points to the right, meaning that our median would be somewhere over here to the right. So median is actually going to be a little bit above your mean. Let's say it's about here. Well, these values down here are considered extreme values. That's our kind of our outliers. So our mean is going to be pulled up by this. So this means that mean is actually going to be even bigger than our median. So if you have right skewed data like this, meaning you have a tail that's pulling it to the right, your mode will still be where the peak is, right over the peak. Your median will be a little bit bigger than it, meaning it's a little to the right, and your mean will be even further to the right of that. So this would be right skewed, which means it's going to pull the mean up a lot, it's going to pull the median up a little bit, and it's not really going to change the mode. If you have the opposite situation, where you have a long tail kind of going to the left, this would be left skewed. And just like before, if you look at your peak, this is where your mode would be, which means that your median is going to be pulled a little bit to the left, let's say here, so it's going to be less than your mode, and your mean is going to be pulled even further over to the left, which means that your mean will be the smallest. It will be pulled the most to the left. So when you have symmetric data, we are going to have mean equals median equals mode. When we have right skewed data, we have that our mode is less than our median is less than our mean. And when we have left skewed data, it means that our mean will be less than our median will be less than our mode. And this is kind of what I was telling you about, is that when you have perfectly symmetric data, or basically symmetric data, so very close, then median and mean are the same. They're basically interchangeable. But what happens as the data gets skewed further from that center point? Well, mode's not really going to be affected by it. Median is going to be pulled a little bit in the direction, right? Because you can almost think of it as adding more data points to that side. But it's just going to move a little bit. Mean, on the other hand, will be pulled far out. So if you have right skew, it's going to be pulled far out to the right. If you have left skew, it's going to be pulled far out to the left. And this, again, is why mean sometimes can be problematic. Because if you have very skewed data, like, for example, something like this might be those net worths of individuals in the United States, you're going to have some very extreme values where you're going to have some people out here pulling that tail very far out. It might not be a lot of them, but it's still going to be enough to pull that mean to the right. The median will pull by a little bit, but not a lot. It's just going to be pulled up by every person. For every billionaire there is, they can be counteracted by one person who's just less than the median. Whereas if you have mean, that billionaire would take many, many, many people below the mean to actually, counteract that person, that one person. So this is why, again, mean, median, and mode can all be important in their own ways. Mode can be used when you have data that's qualitative, or if you just want to know what is the most common outcome. And if it's symmetric, it'll be equivalent to your mean and your median. If you have symmetric normal data, we like to use mean because it works really well in a lot of calculations. And if you have skewed data, generally mean is going to be heavily affected by that. Now you could do something like a trim mean to try to deal with that. There's other ways you could try to work with that, or if depending on what you want to do, you might just want to focus on median because it's not very affected by those outliers. So that is it for section 2.3. When we go on to 2.4, we'll be focusing on methods of calculating variation in different ways. Thank you for watching. To continue learning, click the linked video here for the next lesson. If there's a topic you'd like me to cover, let me know in the comments. Don't forget to subscribe, and I'll see you in the next video.